Today, my Secret Santa gave me beef jerky and Mountain Dew. I'd say there is nothing quite as good as Mountain Dew at 7:30 in the morning. So I'm ready to go. I hope you guys are too. So today we're going to be doing solving absolute value inequalities. And there's one thing I really want you to get stuck in your head. When you're dealing with less than equations in this section, I want you to think of the term less than. When it's less than, it's less than, an and statement. And when it's greater than, I want you to think of great or than. Okay, so less than and statement, great or statement. So we're dealing with things like this. The absolute value of b, that's what this says here at the top. Absolute value of b is going to be less than 5. So because it's absolute value, that means we have to make the positive and the negative solutions. Well, the positive solution is going to be pretty easy. We just do b is less than 5. Nice and easy. And the negative solution, now this is where it gets tricky. We have b, and we know we have to make this term negative, but because it's an absolute value, we also have to flip the sign. Okay, so on the negative side, we have to make it negative, and we have to flip the side now. So we should always have signs pointing two different directions. And because this, we would read this statement as b is less than 5. That means it's less than, so it's an and statement. So we have b is less than 5 and b is greater than negative 5. So we should have, here's negative 5, here's 5, and we know that the b should be in between these 2 points depending on how you shade. And because it's an and statement, we should write it as an algebraic solution. So it's negative 5 is less than b, which is less than 5. Okay, that's an and statement. An or statement, well, this is another less than statement. So let's do one more. Let's get a little bit more technical here. Sorry about that. So this is positive and negative. If you'd like to try to pause this one and do it on your own, give it a shot. So this should be x minus 4 is less than 3. This will be x minus 4 is greater than negative 3. So now we solve. So we get x is less than 7, and over here we get x is greater than 1. It's less than, so it should be and. So we have 1 and we have 7, and because it's and, we're going to be shading in between. Algebraic solution says 1 less than x less than 7. X is in between these two numbers. All right? Now we're going to come back to that one in just a little bit, but I want to do this one first. Okay, so we're not going to pause this here. So for this one, the absolute value here is not by itself yet. So I'm going to get rid of this 3 first. So I have absolute value of x plus 1 is greater than or equal to 5. All right, now we have to do the positive and negative solutions. Okay, so the positive one's always easy. X plus 1 is greater than or equal to 5. A negative one where it gets a little different, x plus 1, we have to flip the sign, less than or equal to negative 5. Alrighty? So then we subtract 1, so we get x is greater than or equal to 4. And over here, whoops, what am I doing? So we get x is less than or equal to negative 6. Now, this right here in the original problem, it reads x plus 1 minus 3 is greater than or equal to 2. So greater than is greater than, so it's an or statement. My graph gets pulled down all the time. So we now have an or statement. So we have the 4 here. And the x is going to be bigger, so I'm going to shade to the right. And then we look at the -6 here. The -6 is bigger, so the x is smaller. Shade to the left. Because it's an or statement, we do not have to do an algebraic. Greater than, less than. Okay? And last one, I want you to try this on your own. You have to get rid of this 2 first, and then do positive and negative solutions. Alrighty. This is about as tough as they get. So now we have 2x plus 3 is less than or equal to 8. Positive solution, negative solution. So we get 2x plus 3 is less than or equal to 8. And over here we get 2x plus 3 is greater than or equal to -8. Now we solve. -3, -3. 2x is less or equal to 5. Divide by 2. And Jade yesterday asked me if she can do decimals here. I think decimals are fine. Just be consistent. Don't be switching between decimals and fractions at will. Really stick with one. I like fractions. But if you like decimals more, there's no problem there too. So x is less than or equal to 2.5 there. Here, -3. So we get 2x is greater than or equal to -11. I divide by 2. So x is greater than or equal to -11 over 2, or -5.5. And this original is less than or equal to, so it's an and statement. So let's graph. So the x is going to be smaller than the 2.5. It's going to be less than or equal to. Smaller than the 2.5, so it's going this way. And it's going to be bigger than the -5.5, so it's going to go this way. We need an algebraic solution, so you can have -5.5 is less than or equal to x, which is less than or equal to 2.5, or you can do the fraction, which I think looks a little bit easier here. But either way is fine. Alrighty, I think that's everything.